the shortcut and you open MATLAB, and the whole windows are like this, and it consists of several windows, and this is showing the current folder. It's a path you're working right now. And first you should click set path. See here, can you see clear? I don't know how to enlarge this. And you should set present path into the MATLAB search path. Choose the path, present path, and click save. And then this path is set as your MATLAB working path. This is the first step. And now you say this is the layout windows, and this is current folder. Show what is the files listed in the present path. And this is the we usually use the most is command window. And you should type your command, type your code here, and let this code show what is your code and what is the result for the command for the code. And the workspace is for saving all the parameters of variables during your coding. Here, name is the variable or parameter name. The value is the value that you let the variable or parameter be. And this is command history. And this it helps you to remember all the command and the code history you just typed. And sometimes you may use the same command several times, and then you can find your command here and just select it and paste here. So it's coming. Good morning. And this is the whole layout windows for MATLAB. And at the home tab, you see new script, new open, same as other apps too. This plot is showing all the figures of the plots you just plot. So now today we just to learn some easy codes to set your transfer function. So how to let MATLAB help you to work on transfer functions. We can have some examples according to the textbook. So let's find a system first. So about the transfer function. So turn to page, maybe let's see. Okay, turn to page 66. And you see the very first line. Below the very first line, there are two equations showing two different transfer functions. See there, GS. See these two. Then how to let MATLAB showing the same transfer function in command window. So there's some codes you should remember first. And we type the code according to numerator and denominator, and according to their orders. What does that mean? So same here. For the first transfer function, ys divided by xs and equals to, what is the numerator? 6 times s plus 7, right? And if we want to type 6 times s plus 7 into the command window, so first we should you can write whatever letters you like. And for me, I usually type num for numerator, short for numerator, and let num equal to the bracket here. And for 6 times s and 7, you should write. See here, what does this mean? And this matrix means put here. If you type this code into command window, what does it mean? It means for your transfer function, the numerator is because 6 is a coefficient for S order 1. And 7 is actually for S order 0. So according to the order numbers here, 1, 0, so you write 6 first and write 7. And then click enter and showing the type, just type a matrix, and the value is 6, 7. And for denominator, I usually type den for denominator. And for this denominator, according to the order of S, so what should be the matrix? 5, 2, 1, 2, right? According to the order of S, see? So here we type 5, 2, 1, 2. And how to let the numerator and denominator? We just type in, change it into the transfer function. Here is a code. Maybe you let the upper G be the GX. And then here is a function, TF, means you want to get transfer function from what? From the numerator and the denominator, you just type in. And then see here? So this G is the transfer function for the numerator and denominator, you just type in. And it's totally the same with the textbook, right? This is the first step. How to get the transfer function you just want. So what if there is a difference maybe for if there is a transfer function what if the transfer function is like this? We don't have the number of S squared. So the order is 3, 1, 0. We missed the order, second order. So how to type this denominator? Remember, if according to the order of S, and between its order, you can, maybe there's some order missed, and then you put 0 instead of this. So if you want to type this,
because of constant.
yeah. So then if you want to type in this, so it should be like, because for S squared, you don't have a square, so you type 0 instead, and 1, 2 still. And then use the same transfer function code. See, this time, we got this. Exactly what we need. This is the very first step to type in transfer function according to the order of S. The descent order. So this is, so maybe I suggested to write this code in code because we don't have this content in textbook and we don't have PPT for this. Then maybe you should write down in code for you to use later. First, type in the numerator and then denominator and then
plus 8.
TF, transfer function.
Oh, that's
TF,
here.
yes, short for transfer function.
Numerator, denominator. And then enter.
Yeah. So this is the first code I want you guys to learn.
And then enter.
And then,
Now see. After this, you need to press enter. Then we got the answer.
what is your question?
My question is after write this one, TF transfer functions.
Yeah, enter.
Numerator, then we can press enter.
Then press enter.
And
Yes,
then we
press
got
enter.
answers. Okay.
After you type each code, just press enter. Press enter means let the MATLAB running this code, this line.
I understand. That is very important.
And here is another expression for showing transfer function, not according to the order of S, but in zeros and poles, zeros and poles and again. So if the transfer function is showing in another expression, how do we type in the transfer function to MATLAB? So let me find an example for that. Oh, let's turn to page 110. And see for the pole and zero. And here is an example showing a system in the form of zeros and poles and again. That is GS equal to what? The numerator is gain k, and zeros s plus 1, s plus 4, and denominator is s and s plus 2, s squared plus 2 times s plus 2. Here, see? Suppose, because there is a k here, we let k be 10, okay? So this transfer function becoming okay. In order to make this easier, we just let maybe, okay, we try typing this. So what is the gain for system? 10. What is the zeros for system? Minus 1 and minus 4. So what is the poles for system? 0, minus 2. See, then how to let MATLAB show the transfer function in form like this? Of course, you can just do the calculate and let it be the form of S order according to. It's okay. But since we use MATLAB, so we want to MATLAB do it for ourselves. So then, first, we let the value 10 be the value. Oh, thanks a lot. Thanks a lot. Thank you. Okay. First, we type k equal to 10. Means we let the gain be 10. And then, how about the zeros? We can let a matrix named Z be the zeros for this transfer function. So it should be minus 1 and minus 4. Here, and then how about the poles? 0, minus 1, and 0, or minus 2, minus 3. Right? So at this time, we see we have again here, we have zeros here, and we have poles here. And now we use the code is no longer transfer function. It's ZPK, means this transfer function is consists of zeros, poles, and gain. See? Then we tap enter and let MATLAB run in this line, this code, and we get transfer function in the form of gain, zeros, and poles, just like this.
So this is question. How I got answer?
Good.
How can we get answer?
Get what answer? I just, this is the very first step. Just the very first step, you should let the MATLAB showing the transfer function you need. Then you can do some questions, to solve some questions according to the transfer function. So this is the very first step. So I'm writing this down. Can I erase it? So this is another several lines of codes help you to showing the transfer function in form of gain, zero, and poles.
What happens if you misarrange the letters?
Arrange oh, it's okay. It's no orders. You can put the minus 1, minus 4, which before which is okay. Just because zeros, because this way. Right? It's okay. Even if this is 1 or this is. So the order for zeros could be minus 1, minus 4, or minus 4, minus 1. It's the same. So it's different from the way you use TF code, because the TF code is very strict on the orders, because you should obey the orders according to the descent order of S. That's the difference. So if you use this way, it's okay, the Z and P, which order, it's okay.
How about inside the brackets? Inside the brackets, like
This
VZK or something.
ZPK, this order should be obeyed. You should obey 0 first and post and K. Okay then. And then we can do some questions as you asked. How about to calculate two transfer functions in series? Let's see an example here. Let's see if I can find an example here. Okay. First, we get let's see how to do this. For transfer function 1, we have Now we have two systems. Transfer function 1 is, and the transfer function for system 2 is. If we want to calculate what is the result for these two systems in series, then very first step, you should type in the two transfer functions in the MATLAB, right? And what is this? The numerator for transfer function 1?
0.
0? No?
1.
1. We still put 1 here.
1.
So we can let, maybe let numerator 1 be 1. And how about the denominator?
1 minus 1, 2.
1 to 1, just 1 to 1. This is the trap here.
No. We need to.
Actually, we have 0 here, 1. For the order of C, we should have the S order 0. So, for this denominator, the number should be 1, 2, 1, 0. See here? If you miss the 0, the results will be different. 1.
Well, option.
You can see here. If we type 1 to 1, as you wish, we don't have 0 here, just type 1 to 1, and then use
G. We need to underscore. Or G underscore 1.
it's okay, you can write just,
Okay.
it's okay. It's just the way you like.
Okay.
And for transfer function 1, if we just use 1 to 1 for denominator, you see, it becomes s squared plus 2 times s plus 1.
Oh, I got it.
Yeah.
It means
You miss the 0 for s order 0.
I understand.
See here?
Power is 2, that means it's 3.
Yeah.
And power is 3, that means it's 4.
So you should add a 0 here. And let's see if we add it. Now, the result is the same. Because we treat 0 as 0 times s 0. See here? Okay. Then how about the second? It's easy, okay? Second is
It's
easy.
1.
The
Numerator 1.
still 1. And how about denominator?
Denominator 1, 2, 1.
Just 1 to 1, right?
Yeah.
Is this what we want?
Yeah.
This exactly with the
Yes.
G2.
Same.
So how to do to let this two systems be in series? There's the code you should need. Maybe we let the G after G be the result after G1 and G2 are in series, and then you type this means G1 and G2, these two transfer functions are in series. And let the result be the bigger G, the upper G. So type enter. So the MATLAB just help you to do the calculate for G1 and G2 in series. We got this result. So it's much easier compared to you calculate it yourself, right? Then how, if G1 and G2 are not in series, but parallel. Then what should be the code? You can guess. See, if we do the series to series, if we do the parallel, it's easy, right? So now we change another letter, not G, maybe just P, okay? P be the result for G1 and G2 are in parallel. So what should be the code for parallel code? Parallel code. Parallel. See, we type the code parallel for G1 and G2 and let the result be P, upper P. Then show here the result upper P is the result that these two systems are parallel. You can calculate yourself to see if the computer does right or not. No need? Trust it. Okay, so it's much easier if you use MATLAB, right? It's so much easier. So how about the feedback? Because if you want to do a simplifying for a diagram, so you may make the situation series, parallel, and feedback. So how to calculate a feedback transfer function? Guess what the code is? Guess what the code is? Just feedback, okay? But the situation, yeah, but the way you use it is a little bit different here. So let me write so I should write this too down. Okay? Okay, then how about the feedback? Feedback. Unless you use the transfer function for the first system and transfer function for second, and then you need to write a value. -1. What does -1 mean? Guess. What? Ah, yeah, you're right. This -1 means these two are in a feedback loop, and this loop is a negative feedback. And if you write, or just positive one here, means this feedback is a positive loop. So this is the symbol to show this feedback loop is negative or positive. So we just use the previous G1 and G2 for this, okay? Let the F be the result of feedback. So G1, G2, and -1. This means G1 and G2 are in a feedback loop, and the feedback loop is a negative feedback. So we get this. Easy? Much easier. See? Okay, then we can solve our homework in chapter. Okay. Page 96. I know you know how to solve this process, every step, you know. But for the calculating, maybe each of you have different final answers. Do you have, any guys got a final answer? So we can use computer, use MATLAB to help us, okay? But first, For the simplifying, you should do it yourself then. And this time, okay, just try this again. First, we talked before, I want to move this high point before G3, okay? G3 is still here, and here we have right? Is it right? Okay then? And see this. And for G2, H2, G3, but this is different because we don't have the actually value for G2, H2, G3 then. So first you should define the variable. Let's see how to define the variable here. Here is a code for you to clear the screen. CLC, to clear the command windows. Okay, then first we should define G2 as a variable here. And H2, G3. And then let's see. Let's try this. okay, maybe I made a mistake. Since we don't have the value for each one, and you just set G2, H2, G3B, the variables. And here, the feedback language is no longer used for variables. You should have exactly the value for G2, H2, G3 here. Okay, maybe let me think of another way later. Let's find an example. We can see here. Don't have any example showing here the exactly value. Okay, you just choose a transfer function randomly, okay? We see a second order transfer function here. If we want to know for unit step response, if we want to get the curve, if we want to plot the curve for this, if the input is a unit step function, so how to plot this curve? You can't plot it just by calculating, it's hard, right? But MATLAB can help you to do the plotting. First, very first step, type in the system into MATLAB. So what is the numerator for this system? 9. And how about denominator? 1, 4.5, and 9. G is the system we want, right? Then if the input is a unit step input, how to see the response for it? First, you should define a time. What is the time you should define? Time is what? It's the value of x-axis, right? If you want to see the curve maybe in this way, then the time, the length of the time, means you want this figure show how long is the x-axis is. Then how to define the time? Maybe we'll let t be the time. And time is from, of course, 0, right? Yeah, maybe here we want to see 20 seconds. So this is mean the axis, the length of the axis is 20 seconds. And from the beginning when t is 0, means the very beginning, 0. And we should be between these two is the sample times. Means because we know the computer is a what? It's not a continuous system. It's a discontinuous system. We just can't get in the, you know, you have you ever learned the signal A, B, and DA? It means the computer receiving the signals just according to each sample time. So we get the data just like maybe between every sample time we get a data from the computer, and after several sample times we get a lot of data, like a lot of dots, and then the computer will connect the dots with a very like curve, and then finally you get the curve for the response. So between these two, you should type the sample times you want. Usually we will let the sample time not very big or not very large. Means 0.01 means the computer will calculate one time within 0.01 second. And then here you see, this is every second the sample time showing here. We can see 0 and another sample time is 0.01, and then 0.02, and then 0.03. Is every time, every sample time. Means at this time, computer will do the calculate once. And now we have the transfer function, and we have the XXST. Then which code we should use to get the response? Very easy, just step. Step means unit step. And see, we have the system G here, we have the time here. See, this is the curve for this system under the input of a unit step. See, so have a very little overshoot, and it's being in a stable situation within like maybe 3 seconds. And if you are not in this window, then click the right button of your mouse. It will come out a menu here. And here is a menu labeled characteristics. Peak response help you to find what is the peak value at the peak time. Settling time, it means it will label a symbol here to show what is the settling time for the system. And the same as right time steady state. Let's see how does it work. If we choose peak response here, and see there is a dot labeled here, and you put your mouse here, this showing all this information about the peak overshoot. System G is the transfer function, you give it the name G. And peak amplitude is the value of the peak value. And overshoot percentage, it just help you calculate out. You don't need to calculate yourself. And then what is at time? 1.58 means the peak overshoot happened at time 1.58 seconds. Easy? You don't have to calculate, use those equations to calculate. It just plot this out, and the system will help you to find all the figures you need. And then settling time here, another, also the same system, right? G. And for this system, the settling time is 1.91 seconds. Same for the rise time and steady state. You can find all the figures according to the characteristics label. This is the way transfer function. Then you define the time t-axis by this code from 0 and what sample time according to you, and then end it in what second according to you. Then you have the transfer function, you have the time. You can use to get, I just close the window, to get the response curve under input. This step means what? Unit step. Okay. Here is another code besides the unit step. If the system is under input of impulse, a unit impulse, what should be the code? Guess. Just impulse, okay, easy. Did I make it right?
No, it's right.
So, yeah. See, this is the same system we just have. Under the input is different now. It's unit, it's no longer unit step, but it's impulse signal. So this is the situation of the response according to the input. It's an impulse. So should we have a rest? Okay. You find it interesting how to use MATLAB in frequency response analysis of control systems. When we finished the Nyquist diagrams, I said you just need to know what is the meaning of Nyquist diagrams, and MATLAB can help you to plot Nyquist diagram. So next, we're going to learn how to use MATLAB to help you to plot the Nyquist diagram. Do you still remember Nyquist diagram? From omega, from 0 to infinity, and to see what is the frequency characteristic the system will change. Okay, let's see example here. Turn to page 133. So example 7.4 is asking you to plot the Nyquist diagram for the system with the transfer function showing in the below. GS equal to so very first step, type in the system into MATLAB command windows. So what is the numerator for the GS? 100. Yes. And how about the denominator? 0.01, 0.1, and 1. So okay, very first step, type in the system, and then how to draw the Nyquist diagram. Here is two solutions. First one, I guess what the code is. Nyquist, yes. Just G here. Let's show. Let's see what's the figure. And we can turn to page 134 to see the figure 7.11 is the Nyquist diagram, right? But Nyquist diagram shown here and the computer is different from the figure in the textbook. Why? See, the figure in textbook from omega from 0 to infinity, it should be distance 100 is okay, right? From 100, and here is from 100. And then in real axis from 100, we have a circle, the curve here ends in original point, right? This should be the curve, like in the textbook. But why we have another curve in the upper half? Why? Because MATLAB is not only think about the situation when the curve changes according to omega from 0 and infinity, but also consider about the situation when omega is from negative infinity to 0. See? Usually, we just think about situation when omega, the frequency, is bigger than 0. So we consider the situation when omega is growing from 0 to infinity, and this is plus infinity, right? But the MATLAB still consider about another situation when omega is from minus infinity to what? To 0. That is to say, MATLAB is consider what is the range for omega. The MATLAB is think about the whole range for omega, no longer 0 or plus infinity, but minus infinity to plus infinity. So see this curve from here, have arrow here, ends in here, means this is the start point, but omega equals minus infinity. And when omega is going to 0, the curve changes to the situation when omega equals 0. So the textbook is only about half a range of omega, and the computer or the MATLAB think about the whole range. But actually, in our real projects or in real systems, we don't let the frequency be a negative number. So we just think about omega during the range of 0 to plus infinity. It's enough. This is just the whole mathematical way to think about the both sides. So that is why the plot, the figure here shown here, is different from figure in the textbook. And another solution, we have numerator for the system, and we have denominator for system. We don't need the code transfer function to get the system transfer function. We can directly use numerator and denominator for system, and we can save this. So directly use Dec and Nyquist, we get the same result. See here? So if you know the system's numerator and the denominator, you can just skip the step, use transfer function code, but directly use Nyquist to plot the diagram for system. Then another kind of diagram we've learned is what? We also have assignment for that. What? Bow diagram, right? Okay, see example 7.6. This example is asking you to plot the open loop flow diagrams for this control system. So the open loop transfer function is given in form like this. Can you find a way to type in this transfer function into the command window? It's not the form according to descent order of S. And it's also not easy to use zero and pulse in this transfer function since we have this. Right? It has no real solutions. Right? It's a pair of roots. We consider the J complex solutions. So how to type in this transfer function into the command windows? Can you find a way? If for me to do this, I will. Can I? This in series of this. Is that right? We can divide this into two transfer functions in series. One is this. Another one is this. Right? And for this, we can type in this in form of gain, zeros, and pulse. And type in this in form of the descent order of S. And then we have these two systems. And they're actually in series. This is my way to do this. So let me do this first. How about again for this one? Right? What are zeros? -3, right? What is the pulse? 0 and -2. And use what? Is this the transfer function we want? Right? Then how about this one? This one is easy, right? One, 1, 2. So 2, 1. No. 2 times TF. Oh, bracket is not. Right? S squared S plus 2. So these two are in series. So let the G is this what we want? Is exactly the same in the example 7.6, right? So finish the very first step. we type in the system into the command window. Then how to draw the boat system, the boat diagram. What is the code? Boat, just boat. Easy. You just type in boat and the system's name and the MATLAB plot the boat diagrams for you. And this one is what? Magnitude, right? This is the face. And we can see, compared to the diagram, let's see the amplitude and magnitude is shown in figure 7.28 on page 154. Actually, you see the curve. It's a little bit different from in the book. The book is what? Asymptotes. Several asymptotes consists of several asymptotes. So they have very large changes when two asymptotes meet each other. But MATLAB drawing here is a very slight curve because it's not plot the asymptotes, but it is plotting the exact curve for a system. But if we do it ourselves, we just do each typical length, right? Consider each typical length and consider the break frequency to draw each asymptote for each typical length. So it's not the exact curve of the system, but the asymptote. But the computer plot exact curve for system. So it's a little bit different. And about the phase. See the phase shown in figure 7.29. It's from what? Minus 90 degree to minus 270 degree, right? And here, the phase is the same. So this is the way, how do we plot bow diagrams. Actually, it's same with the Nyquist code. If we know the system's numerator and denominator, we can skip that step to calculate the transfer function. So it's the same with Nyquist diagram. So, did you do the assignments? Assignments, thank you. Plot the bow diagram. DP 7.2. Have you tried to plot yourself? No, not yet. So let's see what is the result if MATLAB did the problem. So first, how to type in this transfer function. We can treat it as two systems in series. One is what? We can keep the k 1250 with s plus 2 and with denominator s squared in transfer function 1, right? And for transfer function 2, we can have s squared 6 times s plus 25, so same as the previous one. So for the k here, let's change into 1250. And for the zeros, it's what? 0 is minus 2, right? And how about the pose? How about the pose here? if we consider S squared, how many poles? 2, and each one is 0, right? S squared. So we should type 0 and 0. Let's see if the answer is right. So let G1 be the ZPK for the right? We have S squared here because we let the poles be 0, 0. So we get S squared. If we only have zeros, here should be just S order 1, not S squared. So you should pay attention to the details. And how about the transfer function, the second transfer function? Number is 1, right? And how about denominator? It's what? 1, 6, 25. And then do the upper G. Is it the transfer function you should think about? The same, right? Is it right? No? Let's see.
6 is
Oh, miss 6 here.
6 is
Right? Is this time right? I missed one cup. 100 is plus u squared is squared. And 60. Is it right? And then plot the boat. Here is a tips where if you pull up some figure, and if we just type in, you see the figure is shown in this form. It's hard to know every point you want to learn what's the value because we don't have grades on background. So you can have a code is grade on. You see? Who's coming?
I'm just patient.
So we have grades on background, so it's easy to know each value according to the two axes, right? And this is an exact curve, but if you draw yourself, you should have several break frequency. You have very sharp changes according to how many typical links you have in. So if you let MATLAB try to plot the both diagram for you, this is the result. So it should be a little bit different in the amplitude or say in magnitude. The upper figure should be a little bit different from what you just saw. Okay, these are all the simple codes. I think it's simple, right? It's not that hard compared with C, C++, or Java, or I think MATLAB is kind of, the language using in MATLAB is a little, it's just like you do the drafts, right? You do the calculating drafts.
how many languages you know? C,
C and C++, and I'm not good at Java. And the most software I used is MATLAB. Yeah, MATLAB is the core, maybe it's the core software for the control engineering. So this is the most used apps on my computer. And
but also C++.
yeah, because if you want to have additional function using MATLAB, you can write your own codes by C++ and add in the function blocks in MATLAB. So it's okay. So MATLAB can store lots of different codes. So let's see the homework. Did you finish it? The assignments in chapter 6? No? So let's see together, okay? So from the unit step response curve, what can you learn from the curve? The peak value is what? The peak value is what? The peak value, let's see, the peak value is what?
0.0.
Right? So what is the peak time?
0.005.
Right? Then what is the PO? Percentage overshoot. How to calculate the percentage overshoot?
E to the power minus 1.
Right?
Yeah.
It's what? Then it asks us to find its open loop transfer function. Then first, we should find its closed loop transfer function first, right? Because the unit response is according to the closed loop transfer function. And if we want to find the closed loop transfer function, this is a second order system. So what is the general form for second order system? Okay? So, first we should know omega n, the undamped natural frequency for second order system, and the
TP equal to
damping ratio, right?
Yeah.
C. If we know these two, then we can write the closed loop transfer function for the second order system. Then how to get omega n and C from the
TP equal to
parameters we already know.
TP equal to pi over omega n
PO.
minus cos squared.
We have equation to calculate PO is what? E in order is what? Minus cos pi.
Plus is to be
And then square root 1 plus cos. So we have this equal to this. This is actually 0.3, right? Then you can calculate this according to this, but it's a little bit hard.
Yeah.
Alright? Then how to calculate for omega n? We know cos according to this. Then how to calculate for omega n? We have this. We are not use that. So found the equation has relationship with peak time and cos and omega n. Then we know TP. We know cos. Can calculate for omega n. Right? Is the idea? Is that the idea? There are lots of equations, but you should choose the right one. You should know first, what is the already known parameters, what is the unknown parameters, and you find the relationship, find the equation between this, and calculate for the unknown one. And then if we know cos omega n, we can have a closed loop transfer function. Then how to
Omega n square root over.
yeah, then how to find the open loop transfer function?
So we know the loss TP TF equal to omega n square over
Yeah, then
yeah.
if we know omega n and c, we know the GS, but this GS is a closed loop transfer function. But the question is asking you to calculate for open loop transfer function. Then how to get open loop transfer function from closed loop? You should pay attention to the question itself. This is a unit negative feedback.
But see, we know omega n, we know Cauchy, so easily we can get TF.
Yeah, but the TF is not open loop TF, it's closed loop TF. The question is now asking you to find open loop TF. So this is one more step you should do. Suppose we already calculate out for this, that since it is a negative, so let this be the G closed loop, GC, okay? GC for closed loop should be G open loop. Since it is a unit negative, so this should be a plus. And it's a unit, so the HS equal to 1. So for unit negative feedback loop, the closed loop transfer function and the open loop transfer function has a relationship like this. So you know this is GC, closed loop. You know GC now, then substitute GC into here and calculate for G open loop transfer function. This is the process. So you can calculate during the assignments, you can according to my ideal. Clear? Okay, maybe today we should end up the class a little bit earlier because my voice can't stand anymore, you know. It's already I almost shout out to make sound. It's so hard. Sorry.
Lashi, you're so good. We're sorry, Lashi, you are sick, Lashi, your phones. So I hope you will get that. You're so good.